We're going to review trigonometric functions now. I've tried to break this up into a lot of small videos, so just kind of one thing at a time. So we're going to start with the basics. We have 6 trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. These are the abbreviations that indicate those functions. Remember, when you're taking trigonometric function is just like any other function. It has to be of something. And so when we see these letters here, sin, let's see if I can write sin, we're saying we're taking the sine of some angle, and that angle is being represented by theta. Now, I'm going to go ahead and start with the triangle first. And so it has to be, all of our trigonometric functions are based on a right triangle. So we usually indicate a right triangle with a little square to indicate where the right triangle is. You can't use it for other triangles. We have other things in trigonometry that we do for other triangles, like the law of sines and law of cosines. I'm not really going to get into those in the review here, but I do want to go over the basics of trigonometry. Okay, so say we call this angle theta, and a lot of times we do use Greek letters for them. Okay, when we're talking about that angle then, a lot of times they'll mark an angle with an arc to indicate that's the angle. Then the 3 sides of the triangle have labels according to that particular angle. And so we say the side over here is the opposite side. I'm going to abbreviate it. Well, I'll abbreviate later. Opposite, I'm going to run into my other thing. But, and then the side down here is the adjacent. Well, that's not how you spell adjacent. If I can spell adjacent, that's why we abbreviate. And then the side, the long side, the one across from the right angle, that's the hypotenuse. Okay, so that's that side right there. And the 3 sides of the triangle, their ratios, that's what forms the trigonometric functions. So sine of that angle that I have marked, theta, is opposite over hypotenuse. Now that's true even if I had marked the other angle, like the one that doesn't have a piece. I could have gone that angle, and then it changes the orientation for the sides, okay? I don't want to get into that on this particular problem, but hopefully this is just bringing back some happy memories. Okay, cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. Now, those ratios are what we want to remember when we're doing our trigonometry, okay? The other 3 functions have a relationship to the first 3 that we talked about. Cosecant is the reciprocal of sine, and so it's hypotenuse over opposite. And then secant is the reciprocal of cosine, which is hypotenuse over adjacent. And then cotangent is the reciprocal of tangent, which is adjacent over hypotenuse. Or no, oops, over opposite. There we go. Okay, so that's one way you can think about the trigonometric functions and how their ratios work. I always use that. There's an acronym out there, SOHCAHTOA or something. I never remember that. But anyway, if it helps you, you can use that. That is the basics for a right triangle and the relationship of the ratios of the sides and how they relate to the trigonometric functions. Okay, now we're going to go to a point in a quadrant system. So say I have a point out here, some x comma y, and we're used to doing this because of our graphing. Well, the idea then is there's some line from the center out to that point, and you could say that there was a circle that would contain that that line segment as the radius, okay? So we're going to mark that with an R. Now, you might be thinking, oh, the unit circle, because you've heard of that before. We're not going to talk about the unit circle right now. Right now, we're just going to say R is some radius. So it could be a big circle, it could be a little circle, we don't know. But there is some point out there that you could draw a circle through, and from the origin out to that point, make that a radius, okay? So hopefully you kind of get that idea. Now, because of that, we can form a triangle right here, if we drop a perpendicular from that point down to the x-axis. And then that triangle is a right triangle, and we know the value of the three sides. This side here would be the y value, and this side down here would be the x. So again, you could think of your theta being here. I don't have a lot of room to make that a theta. I'll try. Theta. Theta. Okay, well, that's just the cameras. Anyway, that angle then, you can use, instead of writing out the words opposite, adjacent, and hypotenuse, you could use those values that we have for the three sides of the triangle. And so it's still going to follow the same thing. So we could say the sine is, in this case, it would be the opposite over the hypotenuse, which would be y over r. And then the cosine would be adjacent over hypotenuse, which would be x over r. So you look at that little right triangle that I have kind of drawn in blue and green, and you can see the sides, but they're in terms of that ordered pair now, x and y. Could you figure out the value of r? Yes, because of the Pythagorean theorem, if you knew x and y. Okay, oops, I don't know what that was. Okay, and then tangent would be opposite over adjacent, or y over x. So sometimes it's really helpful to think of a triangle in standard position and using the values of a point in terms of x and y. Okay, and then we'll continue to do these, the reciprocals. So the cosecant is going to be r over y, the secant is going to be r over x, and then the cotangent is going to be x over y. Okay, so those are the basics, looking at it as a triangle, just out in the world, a right triangle, and considering the sides being the opposite, adjacent, and hypotenuse for a particular angle in the right triangle. And then we're looking at an ordered pair being graphed and making a triangle out of it and getting the ratios in terms of x, y, and r.